Hi everyone. Here now we are going to discuss one of the theory portions in the subject, that is the poles and zeros of network function. So this portion is actually more of a theory portion, and also it's understanding this is also very simple. Okay, I'm expecting these kind of portions to be asked for small answer questions, like for 3 marks questions and all. Maybe they can ask. Okay, there's nothing to it. All you have to understand is what is the meaning of poles and what is the meaning of zeros, and how to find the values of poles and zeros. That's the only thing you need to understand from here. Okay, the concept is nothing, it's very simple to understand. Here what basically every network function that you have studied previously, let it be any parameters, for z parameters or y parameters or abcd or hybrid or inverse hybrid, any parameters what you have studied so far, each of those parameters are nothing but what we call as the network functions. Those are what we call as the network functions, and we represent network functions in terms of S, because assuming that the circuit is an AC circuit, which means it consists of resistors, capacitors and inductors and all that. It's an interconnection of all these elements. So we say that this circuit is a function of the frequency S. So that is why we call it as an f of s. F of s is nothing but the network function. So we learned that in any network function that you have studied so far, let it be I1 by V1 or I2 by V1 or V2 by I1, let it be any network function, every network function can be written as a ratio of the numerator to the denominator. It's a ratio of two polynomials, that is n of s and d of s. What is n of s? N of s is the polynomial of the numerator form, that is n of s, and d of s is the polynomial of the denominator. Okay, so where n of s and d of s are the polynomials at the numerator and the denominator respectively. Okay, so now we are going to learn what is poles and what is zeros. First, let us look at the definition of zeros. Let z1, z2, z3 up to zn, okay, be the roots of the equation n of s equal to 0, which means these are what we call as the zeros of this function. And how do you find the zeros of this function? By simply equating the numerator, the value, whatever the function of the numerator, equal to 0, and simply finding the roots of this equation, you will find the zeros. Let P1, P2, P3 up to Pm be the roots of the equation d of s is equal to 0. Then in that case, P1, P2, P3 up to Pm are nothing but the poles of the network function f of s. So how to find the poles of the network function? Simply equate the denominator equal to 0 and find its roots. That's all. That is how we find the zeros and poles of the network function. Okay, but this definition, by understanding finding the roots of the equation, means nothing. All you have to do to find the roots of this equation is simply factorize these two polynomials. Factorize the polynomial at the numerator and factorize the polynomial at the denominator. If you have once when you found all the factors, that is once when you represent this f of s in terms of f of s is equal to h into the numerator. Look at the numerator, s minus z1 into s minus z2 into s minus z3 into s minus z4 up to s minus zn. This is how we factor this. I converted n of s, I factorized n of s into this form. Then in that case, you can simply write down the value of the zeros by looking at the value of the individual factors. So you see, s here, what are the zeros over here? z1, z2, z3 up to zn are the zeros. In the same way, if you are able to factorize the denominator polynomial, then you will be able to write the denominator in this form, that is s minus p1 into s minus p2 into s minus p3 and so on up to s minus pm. Then p1, p2, p3 up to pm are nothing but the poles of the network function. That's all. Here h is nothing but the constant called as the scale factor. Okay, so which means basically what it means is that in order to find the poles and zeros, all you need to do is simply factorize or express the numerator polynomial and the denominator polynomial, express both of them in the form of factors. Then in that case, by looking at these factors, you can individually write the values of the zeros and poles. Okay, so now why is the name, where did the name zeros and poles come from? You see, when the complex frequency variable S is equal to any one of the values z1, z2, z3 up to zn, the network function f of s becomes 0. You see for example, the reason why this is called, why the numerator, this z1, the z2 are called as zeros, the reason is because in case if any one of the frequency, we know that this is a function of the complex frequency s is the complex frequency. So if the value of s is either equal to z1 or either equal to z2 or either equal to any one of these zeros values, then the numerator will become a 0. If the numerator becomes 0, then f of s is equal to 0. That is why these roots or these factors are called as the zeros of the network function. In the same way, when s is equal to any of the values, that is p1, p2, p3 up to pm, the network function f of s becomes infinity, which means, like I said before, here the f of s is a function of the complex frequency s, right? Now if this s is equal to p1 or p2 or any one of these values, then what will happen to the denominator? The denominator will become 0. So anything divided by 0 becomes infinity. So therefore this function becomes infinity. That is why P1, P2, P3 and all are nothing but are called as the poles of the network function. Okay. Therefore, the complex frequencies Z1, Z2, Zn are called as the zeros of the network function f of s, and the complex frequencies P1, P2, P3 up to Pm are called as the poles of the network function f of s. Okay. That's it. That's all you have to understand this topic. If the poles and zeros are not repeated, then the network function is said to have simple poles and simple zeros. If the poles and zeros are repeated, then the network function is said to have multiple poles and multiple zeros. Okay? So that we'll see through examples. Okay? We will see the meaning of simple poles and simple zeros. That is, if you have, if every poles and zeros are distinct, then we say that there's nothing but simple poles and simple zeros. But if some of the poles are repeating, that is, sometimes some poles will have some poles will have the same value at the same location. In that case, we say that it's called as the multiple poles. And also, if it's the same, if more than one zero is at the same location or at the same value, then that is called as multiple zeros. Okay. Now this is one of the interesting thing about the poles and zeros. You see, the advantage of poles and zeros is that they can be represented in a graph called as the pole zero plot. We also call this pole zero plot as an S-plane. You see, because we know that the value of S is equal to sigma plus j omega. So this sigma can be represented in the x-axis and this j omega can be represented in the y-axis. So in that case, I can represent this graph in the S-plane, and in the S-plane I can mark the poles and the zeros. So how to mark the poles and zeros? That you need to remember. It's very easy to remember. The zeros, you mark them in the graph using a circle, and the poles, you will mark them in the graph using a cross. So zeros are represented in a circle. So you need to just remember, right? The shape of a zero is a circle, right? The basic shape of a zero is a circle itself. So just remember like that. So if you want to mark a zero in an S-plane, simply draw a circle in that position. If you want to mark a pole in the S-plane, simply put a cross on that location. Now if you look over here, let's take a look at the example. Okay, let's see what I have drawn over here. This is a S graph. Okay, this is an S-plane or a pole zero plot, and if you look over here, if you look in this graph, there are 3 poles and 1 zero. This is the 3 poles, 1, 2, 3, the crosses. These are the poles. And what about the zero? There are only 1 zero, that is over here, right? So if you want me, so if you ask me how to express the location of the poles and zeros, if you look over here, this zero, okay, this is called as S is equal to minus 3. This is a pole. S is equal to minus 3 is a pole. In this example, S is equal to minus 3 is a pole. No, sorry, I'm very sorry, not pole, 0. 0. Okay, S is equal to minus 3 is a 0 because it's a circle, right? So S is equal to minus 3 is 0. Now, if you want me to mark the poles or how to write the poles, there are 3 poles. First, let me express the poles for this. This is called as s is equal to minus 1. You see, this is called as s is equal to minus 1. I didn't mark this graph. Let me mark it over here. This is j, and let this be 1j, and let this be minus 1j. Okay. So s is equal to minus 1 is a pole. Now there are two more poles. How to write the pole for this? This is, if you look at the what is the value of this location over here? This is minus 2 plus 1j, right? This is minus 2 plus 1j. So s is equal to minus 2 plus 1j or plus j. And what is the name of this pole? This is s is equal to, here it is minus 2 and here it is minus 1j. So s is equal to minus 2 minus j. These are the poles of the network function. The poles. This is the 0 and these three are the poles. S is equal to minus 1. That is this pole right here. S is equal to minus 2 plus j, minus 2. See, minus 2 plus j, that is this pole. S is equal to minus 2 minus j, that is minus 2 minus j. This is the pole. This is how we mark the poles and zeros. That's all. So this is how the question will be asked. Obtain the pole zero plot of the following function. That is, they'll ask you to draw the S-plane or the pole zero plot of this following function, or they'll ask you to simply find the poles and zeros. Okay, that is how they asked. So here, let's look at this question. Here, the network function is s into s plus 2 by s plus 1 into s plus 3. Okay, so here luckily already they are given in terms of factors. Okay, instead of this, sometimes they will ask like this. Sometimes, okay, you can't say. Sometimes they'll ask like this. That is s square plus 2s by s square plus 4s plus 3. Okay, sometimes they'll give the question in this form or they'll give the question in this form. Okay, so either way, whichever form they're giving, you should learn to factorize it. So here already the factors are already given. Both the numerator and the denominator are expressed in terms of factors. And here it is actually these two factors are multiplied together, so you will get a basically equation. So if you get an equation, what you need to do is you have to learn to convert this equation in terms of its factors. Okay, that is what you need to do, and that can be done only through practice. Okay, how to convert this is, I hope all of you know that. That is, you see, if you look over here, you need to find two numbers in which if you add them you will get 4, and by multiplying them you will get 3. So obviously the answer is 1 and 3. That's how you learn to factorize it. And here if you look at these two, you can say that s is common, so you can just take s out, so you will get 2 factors. That's how from here you can convert into this factor form. Okay, so now let's find the values of poles and zeros over here. So if you want to find the values of, so just simply look at the factors. That is, how many factors does the numerator have? The numerator have 2 factors, that is s and s plus 2, right? S and s plus 2 are the 2 factors. So which means if I equate the numerator to 0, I will either it either means that s is equal to 0, or it either means that s plus 2 is equal to 0, or s is equal to minus 2. So these two values are what you call as the zeros of f of s. S is equal to 0 and s is equal to minus 2, because there are 2 factors, s and s plus 2. So therefore, when does the numerator become 0? The numerator will become 0 when either s is equal to 0 or when s is equal to minus 2. Because if s is equal to 0, this term will become 0 and f of s becomes 0. Or the other way how the f of s can be 0 is when s is equal to minus 2, because when s is equal to minus 2, this factor becomes 0. If this factor becomes 0, again f of s becomes 0. That is why s is equal to 0 and s is equal to minus 2 are the zeros of f of s. So you see how to write the equation. Remember, see, simply look at the factors and write the value of s. And now let's look at the denominator. In the denominator, there are 2 factors, which means 2 factors means there will be 2 poles, right? Obviously, there will be 2 poles. Now, what happens if s plus 1 is equal to 0, and what happens when s plus 3 is equal to 0? If s plus 1 is equal to 0, then s is equal to minus 1. If s plus 3 is equal to 0, then s is equal to minus 3. So in that case, s is equal to minus 1 and s is equal to minus 3 are the poles of f of s. That's all. See, are the poles of f of s. So Why do you call them the poles? Because if s is equal to minus 1, if s is equal to minus 1, then minus 1 plus 1 becomes 0. This factor will become 0. Therefore, the denominator will become 0, and anything by 0 is infinity. Therefore, f of s becomes infinity. That is why s is equal to minus 1 is the pole of f of s. Now, why s is equal to minus 3 is a pole of f of s? Because if s is equal to minus 3, this factor will become equal to 0, and hence the denominator will become 0, and hence f of s becomes infinity. That is why s is equal to minus 3 is also the pole. Now, next question is how to draw the pole 0 plot. Very easy. Just simply draw the graph, the horizontal line and the vertical line. The horizontal line represents the sigma, and the vertical line represents the j omega, and then you mark over here, this is the origin, this is called as 0. If this is 0, then you can put some space in between and mark the values as minus 1, this is minus 2, this is minus 3, and this is minus 4. Okay, I'm always confident that the values of zeros and poles will always fall on the left half of the s plane. Always, I'm always confident. You'll understand the reason later. Okay. And if you want to mark the vertical points, this is 1j, this is 2j, and downwards this is minus 1j, and this is minus 2j. Okay, this is how you mark it. So first I'm going to mark the zeros. So zeros are located at 0, s is equal to 0, and s is equal to minus 2. So s is equal to 0, let me mark that. I'll use another pen. S is equal to 0 and s is equal to minus 2 are the zeros of f of s. Now, what about the poles? The poles are marked as crosses, and s is equal to minus 1 and s is equal to minus 3. Therefore, s is equal to minus 1 and s is equal to minus 3. This is called as the poles. This is how we mark the pole 0 plot. You see? So what happens is they'll ask you to find any one of the network function. Okay, they'll ask you to find v1 by i1 or v2 by, they'll ask you to find any network function. It can be any one of the parameters also, and then they'll ask you to mark the poles and zeros in that function. So by simply marking the poles and zeros, just do like this. That's all. Factorize it and then mark it on the graph. Okay, let's do another question now. So now let's do this question. Here the question is f of s is equal to s into s plus 1 by s plus 2 the whole square into s plus 3. So here also, as usual, right? It's very easy. Here the numerator, there are 2 factors. At the denominator, there are 3 factors actually. There are 3 factors at the denominator. What is the specialty about the numerator? At the numerator, there are 2 factors, and the factors at the value of s is equal to 0 and s is equal to minus 1. So these are the zeros of f of s. What about the denominator? Well, at the denominator, there are 3 poles. You see, why do you say there are 3 poles? Because there are 3 factors. What are those 3 factors? S plus 2, s plus 2, and s plus 3. You see, because this is s plus 2 the whole square, which means there are 2 factors, s plus 2 and s plus 2. So since there are 2 factors, s plus 2 and s plus 2, then there are 2 poles. That is, s is equal to minus 2 and s is equal to minus 2. So which means there are 3 poles at the denominator. The poles are s is equal to minus 2, s is equal to minus 2, and s is equal to minus 3. S is equal to minus 2 and s is equal to minus 2 is the pole of this factor, that is s plus 2 the whole square, and s is equal to minus 3 is the pole of this factor, s plus 3. You see, this is how we mark it. This is what you call as the multiple poles that we have mentioned in the previous, just before, right? That is, multiple poles means if the poles are repeating, then we call them as multiple poles. And if the poles are unique and distinct, then there are symbol poles and zeros. So here you have symbol zeros, but here the poles are multiple because you have same poles at the same location. Okay? So these are the poles. Poles of f of s. So to mark them also is very easy, right? You can now know how to mark it. So here there's nothing. All you have to do is simply mark the value of, this is horizontal sigma, numerator, vertical line is j omega. This is the origin 0. Let this be minus 1. This is minus 2. This is minus 3. This is minus 4. Okay, after that much is enough, I think, right? This is 1j. This is 2j, and this is minus 1j. You don't need any more space above and beyond. So here s is equal to 0 and s is equal to minus 1 is the zeros of f of s, and for the poles it is s is equal to minus 2. And just to show that there is another pole is equal to minus 2, I will just draw another cross very close to it. Okay, I will just draw another cross very close, just to show that there is another pole on top of that in the same location. That is why I marked 2 times. S is equal to minus 2 and s is equal to minus 2. And the other one is s is equal to minus 3, and that is this value over here. So this is how you mark the poles and zeros. Okay. Now let's do this question. Okay, so here you're going to mark the poles and zeros. So here the question is f of s is equal to s square plus 2s by s square plus 2s plus 2. So here you see, if you look now, simply look at the numerator and the denominator individually. First I will look at the numerator. How can I factorize the numerator? By taking s common, right? Because in both those cases s is common, so it's immediately you can understand, you can take s common, you will get s into s plus 2. So therefore this is the factors of numerator, that is s and s plus 2, which means s is equal to 0 and s is equal to minus 2 are the zeros of f of s. You found that. Okay, very good. What about the denominator? You see, if you look at the denominator cannot be directly be factorized. That is what you need to understand. You see, you cannot directly factorize it. You can try however you want. You can't directly factorize this now expression. So in order to, so it's up. So what will you do when you see an equation which you cannot factorize? There also there is a shortcut method which I want you all to apply. This, you see, the method is this. That is, we already know that a square minus b square. All of you know that a square minus b square is equal to a plus b into a minus b. All of you know this equation, right? This is what you have studied in school. But you all might have learned this equation also. You see, a square plus b square. There's an equation for this also, a square plus b square. And how to write this equation? A square plus b square is actually a plus jb into a minus jb. That's it, right? That means if you take a complex number and if you multiply that complex number with its conjugate, you will get the square of its magnitude. We already know, right, what is root of a square plus b square. That is the magnitude of a plus jb. That is exactly what you're seeing here. Here, what you see here is, you take its complex number and if you multiply this conjugate, you will definitely get a square plus b square. Or in other words, a square plus b square is equal to a plus jb into a minus jb. You are going to use these two expressions in order to factorize expression which cannot be factorized otherwise directly. So for example, just look how I'm going to do this. Okay, I want you all to understand the way how to do that. Is here s square plus 2s plus 2. Okay, so how will I factorize this? In order to factorize this, all you need to do is simply look at the first two numbers. Simply look at the first two numbers. The s square, the coefficient of s square must always be 1. If it is not 1, you should make it 1 by taking that factor common or whatever. By any way possible, you need to make that factor 1. Here the coefficient of s square is already 1, so that's no problem. Now look at the second number, the second expression. Here it is 2s. So what equation can you think of so that you get a 2s in the middle? What equation can you think of in such a way that you can get 2s in the middle? You already know that s square plus 2s plus 1. See here, s square plus 2s plus 1 is equal to s plus 1 the whole square. We already know this expression, right? Simply look at this first two expression and try to create a third expression. Try to create a third term in which that term can be factorized. You see, s square plus 2s plus 2 you cannot factorize, but you can factorize s square plus 2s plus 1, because you already know that s square plus 2s plus 1 is nothing but s plus 1 the whole square. So now I can write this equation in this form. That is, instead of writing s square plus 2s plus 2, I can write it like this. That is, s square plus 2s plus 1 plus 1. See? That is what I did, is that I created a third term over here in which can be used to factorize these three terms. So I created a third term over here purposefully so that I can factorize at least the partial of my answer. So what happened when I factorize like this? Then this can also be written as s plus 1 the whole square plus 1. S plus 1 the whole square plus 1. Now look over here, I have already written that a square plus b square is equal to a plus jb into a minus jb. This a square is this s plus 1 the whole square, and this b square is this 1 square. So, or this can also be written as s plus 1 the whole square plus 1 square. So this is a square plus b square. So in that case, you can factorize it like this, that is s plus 1 plus j and s plus 1 minus j. Just like how you have written a square plus b square is equal to a plus jb into a minus jb. In the same way, you can write s plus 1 the whole square plus 1 the whole square is s plus 1 plus j into s plus 1 minus j. So see, now you have factorized the denominator successfully. Or in other words, the value of f of s is equal to s into s plus 2 by s plus 1 plus j into s plus 1 minus j. See, so these also, that means the numerator has 2 zeros and the denominator has 2 poles. Okay, this is how you are factorizing it. So which means, what are the zeros of f of s? S is equal to 0 and s is equal to minus 2 are the zeros of f of s. And what are the poles of f of s? You see, if you equate this factor equal to 0, you will get s is equal to minus 1 minus j. If you equate this factor is equal to 0, you will get s is equal to minus 1 plus j. So s is equal to minus 1 minus j and s is equal to minus 1 plus j are the poles of f of s. So in order to draw the pole zero plot, first you draw the vertical line and the horizontal line as usual. This is sigma, this is j omega, this is the origin, this is minus 1, minus 2, minus 3, and this is 1, and this is 1j, and this is 2j, and this is minus 1j, and if you go down, this is minus 2j. Okay, so now to mark the pole zero plot, first I'll mark the zeros. The position is at s is equal to 0 and s is equal to minus 2. So s is equal to 0 and s is equal to minus 2 there. Okay, these are the two zeros. What are the poles? The poles are at s is equal to minus 1 minus j and s is equal to minus 1 plus j. So first is s is equal to minus 1 minus j. This is minus 1, it's equal to minus 1 minus j, that is this one over here, and s is equal to minus 1 plus j, that is this one over here. These are the two poles of f of s. That's all. See, so this is how, so you need to learn to factorize those equations which cannot be factorized directly by simply remembering that a square plus b square is equal to a plus b jb into a minus jb. That is, you can, there's nothing but multiplying the complex number with its conjugate. Okay, let's do another question. Now for the next question, right, I want you all to just pause this video, copy the question, and then pause the video again and try to do the problem by yourself. Okay, that's what I want you all to do. So it will be a good learning experience for you. So here also, how to find the poles and zeros. Here the expression is s plus 1 the whole square into s plus 5 by s plus 2 into s square plus 6s plus 13. So now let us do this question. Okay, so here we know that the poles or zeros, first we mark zeros. The zeros are very easy because they are purely factors, right? The poles are going to be a little bit confusing because one of the factor is cannot be. It's not. This is also very easy. You can actually factorize them just using that above expression. Here, s plus 1 the whole square into s plus 5, right? So what are the poles, or sorry, what are the zeros of f of s? In that case, here there are three factors, right? That is s plus 1 the whole square into s plus 5. So which means there are three factors: s plus 1, s plus 1, and s plus 5. So which means there are three zeros. And what are those three zeros? S is equal to minus 1, s is equal to minus 1, and s is equal to minus 5 are the three zeros, are the zeros of f of s. Okay, what about the poles? Well, the poles, one of the pole is s is equal to minus 2. because there is a factor s plus 2, so therefore one of the poles will be s is equal to minus 2. What about this expression? To factorize this also, again, is very easy. See, let me factorize this and show you how it is being done. If you can do it mentally, well and good. Here, s square plus 6s plus 13. Okay. So what you do is try to find a factorizable equation which contains these two numbers, s square and 6s. Yes, we already know that s square plus what is 6 divided by 2? 6 divided by 2 is 3. 3 square is 9. So which means s square plus 6s plus 9 is nothing but s plus 3 the whole square. You see, you can write any expression in this format. Any expression. Okay, in this format. So you see, s square plus 6s plus 13, right? So I can write this as s square plus 6s plus 9. We already know what is s square plus 6s plus 9. This is nothing but s plus 3 the whole square. So this is what I'm going to write over here. So this will become s square plus 6s plus 9 plus 4. Or this can also be written as, we already know that s square plus 6s plus 9 is s plus 3 the whole square. So this whole thing is nothing but s plus 3 the whole square plus, and this 4 can be written as 2 square. You see, a square plus b square is equal to a plus jb into a minus jb, or this can be factorized as s plus 3 plus 2j and s plus 3 minus 2j. You see, this is how we factorize this expression. Or in other words, f of s can be written as s plus 1 the whole square into s plus 5 by s plus 2 into s plus 3 plus 2j into s plus 3 minus 2j. See, this is how we can write, or this is how we can factorize it. So what are so we have already written the zeros. So what are the poles? Poles are s is equal to minus 2, and then this is s is here, when s plus 3 plus 2j is equal to 0, you will get s is equal to minus 3 minus 2j. Likewise, if you get s plus 3 minus 2j equal to 0, you will get s is equal to minus 3 plus 2j. Okay, always remember, let it be zeros or poles, if you see a complex number, definitely there will be a conjugate. Definitely, that's a sure fact. If you look for any network parameter equations, when you factorize it, when you come across any complex pole, then definitely you will come across the conjugate of the complex pole. You will also find its conjugate also. See, let's take this example. This is one complex number, so definitely, and the conjugate will also be there along with it. Okay, so mark these poles and zeros. That is, here the graph will be somewhat like this, right? That is, let's draw this graph, right? This, it will be like this. This is minus 1, this is minus 2, this is minus 3, this is minus 4, this is minus 5. Let's extend this a little bit further. Okay, and this is sigma, this vertical line is j omega, and this is 1j, and this is 2j. This is minus 1j, and if you go down, you can mark minus 2j. Okay, so now let's mark the graph. Over here you have the 0, there are 3 zeros. S is equal to minus 1, S is equal to minus 1, and S is equal to minus 5. So S is equal to minus 1. Okay, I'm going to draw another circle to show that there are another 0 at S is equal to minus 1. Okay, that's why. And also another 0 is at S is equal to minus 5. So I will draw another circle over here. These are the 3 zeros. Now how to mark the poles? One pole is at S is equal to minus 2. So this is S is equal to minus 2. And the other pole is at S is equal to minus 3 minus 2j. S is equal to, this is minus 3 and minus 2j is over here. So this is it, minus 3 minus 2j, and the other is at S is equal to minus 3 plus 2j. So S is equal to minus 3 plus 2j. That's it. See, this is how you mark the poles and zeros. Okay. Let's do one more question so that you will just be able to familiarize yourself. Here, the next question is, let's do this question in this format. That is, let's do like this. That is f of s is equal to s square plus 4 by s plus 2 into s square plus 9. I want you all to do this problem by yourself, okay? So here also I want you to pause the video and try to do the problem by yourself, okay? So here, how to factorize it? S square plus 4 can be written as s plus 2j into s minus 2j by, this is s plus 2, so this is s plus 2. S square plus 9 can be factorized as s plus 3j into s minus 3j. That's it. See, this is how you mark it. So now let's draw the graph, and this is how you get it. This is 1j, this is 2j, this is 3j, and this is minus 1j, this is minus 2j, and this is minus 3j, and let this be minus 1, let this be minus 2, and let this be minus 3. Okay, don't forget to mark sigma and j omega and the origin also. So here the poles are the zeros are at s plus 2j and s minus 2j. S plus 2j means s plus 2j is equal to 0, so therefore s is equal to minus 2j. So s is equal to minus 2j is one zeros over here, and the other is that s is equal to 2j. It is over here. S is equal to 2j, or this is s is equal to 2j, and the other one s is equal to minus 2j. That is over here. Okay. Now look at the value here. S plus 2 is equal to 0, so s is equal to minus 2. So one of the pole will be at s is equal to minus 2. Here s plus 3j is equal to 0, so therefore s is equal to minus 3j, which means another pole will be at s is equal to minus 3j. It's over here. And also s minus 3j is equal to 0, so therefore s is equal to 3j. So another pole is over here. This is your pole 0 plot. Okay.